Okay, and then we know up to this YCF. We know up to this YCF. What is that? YCF is complementary function, that is a solution of associated homogeneous differential equation, which can be written as C1y1 plus C2y2. Now what is that y1 y2? Y1 y2 are the two solution of the given differential equation. Now for example, if you have complementary function YCF as C1 e to the power x plus C2 e to the power minus x, that means this is the value of y1 and this is the value of y2. That means coefficients of C1 and C2, whatever that coefficient of this arbitrary constant C1 and C2, that will be y1 and y2 respectively. So that is YCF is equal to C1 y1 plus C2 y2. Okay, up to this it is clear. Next, what? Yp is equal to u times y1 plus v times y2. Then particular integral. This is what? Particular integral. This is what? Complementary function YCF. Okay, now we want to find particular integral, and just we are letting particular integral as u times y1 plus v times y2. Okay, but what is that value of u and v? U is given by the formula u is equal to integration of this. U is equal to integration of minus y2 f of x divided by w dx, and v is given by this formula. V is equal to integration of y1 f of x divided by w dx. Okay, now what is the w? W is the Wronskian. W is what? Wronskian. So Wronskian w is equal to determinant of y1, y2, y1 dash, y2 dash. Now what is that y1, y2? Which are the coefficients of C1, C2, and we are just taking determinant of y1, y2, y1 dash, y2 dash. And after getting the determinant, we will get the value of w. And after finding the w, our aim is to find values of u and values of v. Just putting the values y2, f of x, w. What is f of x? F of x is the right hand side of the given differential equation. Let me revise it once again. So phi of d times y is equal to f of x is the given differential equation. You know up to YCF, how to find YCF. Okay, YCF is equal to, I'm just calling this as a C1 y1 plus C2 y2. Okay, coefficient of C1 is y1, coefficient of C2 is y2. And then you require to find yp. So yp is equal to u times y1 plus v times y2. And our aim is to find this u and this v. Now for that we have the formula u is equal to integration of minus y2 f of x divided by w dx. And for this we have for this v we have the formula integration of y1 f of x divided by w dx. Now what is the w? W is Wronskian, that is equal to determinant of y1 y2, and take the derivative y1 dash y2 dash. And once you get the value of w, find out u by solving that integral, find out the value of v by solving of that integral. Once you get the values of u and v, just what is the yp? Yp is what? U y1 plus v y2, and after getting the values of u and v, just put here and the value of v here, you will get particular integral. Once you get particular integral, then finally YCF plus yp, YCF plus yp. So this is the process to variation parameter method. Let us see one example, so everything will be get clear. T square plus 1 times y is equal to cot x. So this is a given differential equation, and let us solve it by using variation parameter method. The question is, solve the following differential equation by using variation parameter method. Okay, so consider associated homogeneous differential equation. Okay, so associated homogeneous differential equation is what? T square plus 1 times y equal to 0. So auxiliary equation is what? D square plus 1 equal to 0, and therefore d square equal to minus 1. That gives us d equal to plus minus I roots. Now you tell me what would be the complementary function if you have the complex roots d equal to plus minus I. Yes, if you have d equal to plus minus I, then what will be the complementary function? YCF?
A cos x plus b sin x.
A cos x plus b sin x.
A cos
Correct.
x plus b sin x.
Exactly, because the alpha is what here in this case we have 0 alpha, and beta is the coefficient of I, that is 1. Okay, and that's why e to the power alpha x in bracket a cos x b plus b sin beta x, that formula we have to use, case number 3. And that's why we got this YCF as a cos x plus b sin x, because the value of alpha is 0 and beta is what? 1. Up to this we know everything up to complementary function. Next what? After getting complementary function, you have to let this step. Next, yp is equal to u times y1 plus v times y2. And our aim is to find the values of this u and this v. So I'm just I'm just identifying the values of y1, y2. Y1 is what? Cos x. It is the coefficient of this first arbitrary constant, that is a. And arbitrary constant b, okay, its coefficient is sin x. So y2 is what? Sin x. Okay, and just put these values of y1, y2 in the yp. So we get u times cos x plus v times sin x. And here onward we want to find values of u and v. Okay, so the formula for u is what? U is equal to integration of minus y2 f of x upon w dx, and formula for v as integration of y1 f of x divided by w dx. Okay, let us find out u first. And for finding u, we require w. So let us calculate w. W is what? Wronskian, which is equal to determinant of y1, y2, y1 dash, y2 dash. But what is the value of y1? Y1 is cos x, okay, and y2 is sin x, okay. Its derivative cos x derivative is minus sin x, and sin x derivative is cos x, okay. Now take the determinant, just expand this determinant. So we'll get cos x, okay, cos square x, and this minus become plus sin square x, okay. But cos square x plus sin square is what? 1. And that's why we got the value of w as w equal to 1. Okay, now u is equal to, this is very important, u is equal to integration of the, what is the formula? Integration of minus y2 f of x divided by w dx. This is the formula. Now just put the values of y2 w f of x in this formula. So we get minus as it is, okay. Sin x, what is sin x? Sin x, the value of y2, okay, you can see here y2. And cot x is what? Right hand side. What is the right hand side? You can see here, right hand side is cot x of the given differential equation. Just writing that right hand side. And divided by 1. Divided by 1 means what? This is value of w. Okay, just writing divided by 1. And just we want to solve this integral. So this is equal to what? Minus sin x as it is. Cot x can be written as cos x upon sin x. This sin x get cancelled. We left with the minus times integral of cos x. But the integral of cos x is what? Sin x. And this outside minus sin as it is. So we get the value of u as minus sin x. Okay. Next, we want to find the value of v. Now, what is the formula for v? V is equal to integration of y1 f of x divided by w dx. Okay, and just put the values of y1. What is the value of y1? Y1 is already calculated. It is equal to cos x. Okay, just putting this value cos x, and f of x is cot x, and whole divided by Wronskian, that is 1. Okay, now simplify it. Cos square x. Okay, so we have cos square x integration of cos square x divided by sin x dx. Now next what? How to solve this integral? Yes, any idea?
Cos square x we can convert it into 1 minus sin square x.
1 plus or 1 minus?
1 minus.
1 minus
yes.
sin square x.
Yes, we can replace cos square x term by 1 minus sin square x, and that's why we get this next term. 1 minus sin square x divided by sin x, and just separate the denominator. So we get 1 upon sin x, that is cosec x. 1 upon sin x means cosec x, and this one sin get cancelled. We left with minus sin x. Okay, and now integrate. Now integration of cosec x is what? Log of cosec x minus cot x, and integration of sin x is minus cos x. But already there is a minus, so minus become plus. It is plus cos x. That is the value of v. Once we find the values of u and v, you have to write the particular integral. What is that? Yp is equal to uy1 plus vy2. Okay, just put the values of u and v. That's it. What is the value of y1? Y1 is cos x as it is. Okay, and what is the value of u? U is, you can see here in the box. U is minus sin x. Just writing that minus sin x as it is here. Okay, and plus sin x. Sin x is what? Value of y2, and this v as it is. Okay, log of cosec x minus cot x plus cos x. And after finding v, yp, last step is ycf plus yp. That is a cos x plus b sin x plus this v written as it is. Okay, that is the complete solution. That is the complete solution. Do you understand this method, variation parameter method? Yes. Yes or no?
Yes, sir. Understood.
So this is all about variation parameter method. Let me revise once again the formulas. And if you have phi of d times y equal to f of x is the given differential equation, then in that case you need to find YCF. YCF is what? C1 y1 plus C2 y2, and then you can let yp as u times y1 plus v times y2. Okay, now our aim is to find u and v. For that we require w. So w is what? W is nothing but the determinant of y1 y2 y1 dash y2 dash. You can call this as a Wronskian. And formula for u and v, integration of minus y2 f of x divided by w dx, and formula for v, it is equal to y1 f of x divided by w dx. Okay, once you get the values of u and v, you need to substitute those values in the particular integral, and once you find the particular integral, you have to write y equal to ycf plus yp. That will be the complete integral. Okay, so this is the one exercise for you. Example number 2, d2y by dx square minus 4 times dy by dx plus 4 times y plus e to the power 2x. Let me make it more simple. Instead of 2x, let me take 2x. Okay. Sec square 2x is also simple actually, but anyway, you will get the answer directly. Okay, if you use sec square x term. And example number 3 is d2y by dx square plus y is equal to cosec x, and last is d2y by dx square minus y is equal to 2 upon 1 plus e to the power x. Now you tell me which example you want me to solve here, because I think we have time.
Fourth.
Let's solve like fourth. Okay, fourth. Okay, fourth. Is, yeah, we have space. Solve here. 4. So consider associated homogeneous differential equation. Okay, so associated homogeneous differential equation is d2y by dx square minus y equal to 0. Okay, and therefore auxiliary equation is d square minus 1 equal to 0, and therefore roots are what? Square root of 1, that is plus minus 1, and that's why we have ycf as c1 e to the power minus x plus c2 e to the power x. Okay, and we can identify y1 y2 as y1 is equal to e to the power minus x and y2 is equal to e to the power x. These are just the coefficients of c1 and c2 arbitrary constant, that is y1 and y2. And we got the y1 y2. Now we want particular integral. Next we want particular integral. Okay, so yp is equal to what is our formula? U times y1 plus v times y2. Okay, and
sir,
yes
sir, if we take as a c1 e to the power plus x first and then minus x, and if we take the y1 value as a e to the x and y2 equal to e raised to minus x, then will the answer change at the last try?
No, answer will not change. You will get the same answer. Okay, choice is your position doesn't matter. Okay, yeah, so good doubt actually, good question. U is equal to, we have the formula. I'm just putting the value of y1 y2. So u times y1, it is e to the power minus x plus v times y2, that is e to the power x. Okay, so u is equal to formula is minus y2 f of x divided by w dx. Okay, and v is integration of y1 f of x divided by w dx. Okay, so let us calculate w. So therefore w is equal to y1 y2 y1 dash y2 dash, determinant of this, which is equal to y1 is what? E to the power minus x, and y2 is what? E to the power x, and take the derivative of this first. It is minus e to the power minus x, and derivative of this term is e to the power x, and not expanded determinant. So this is what? E to the power minus x into e to the power x. Okay, minus become plus e to the power x into e to the power minus x, and this will be that get cancelled. E to the power minus x, e to the power x get cancelled, and this also get cancelled. So 1 plus 1 equal to 2. That is the value of w. Up to this clear? Up to W. All steps are clear now? Yes?
Yes, sir. Yes, sir.
Okay. Yeah, good. Now we want to find U. So therefore, U is equal to formula minus y2 f of x divided by W, and just put the values of all values are known now. Y2 f of x W. So y2 is what? You can see here. Y2 is e to the power x. Okay, so minus e to the power x into f of x. F of x means right hand side. What is that right hand side? It is 2 upon 1 plus e to the power x. Okay, just writing that 2 upon 1 plus e to the power x. And what is the value of W? W is what? 2. So just writing 2. Okay, dx. And that 2 get cancelled. It is simply minus outside e to the power x divided by 1 plus e to the power x dx. Okay. And what is the integration of this term? Yes, can you tell me? Minus
log of 1 plus e raised to x.
Yes,
Minus
very
log
good.
of 1 plus e raised to x.
Exactly. Why? The reason is since integration of f dash of x divided by f of x dx is equal to log of f of x. This is the formula. And you can see here the denominator is 1 plus e to the power x, and its a derivative is present in the numerator, that is e to the power x. And so we can use this formula, and according to that formula we have the value of u as minus log of 1 plus e to the power x. That is the value of u. Okay, this is the value of u. Once you get the value of e, we want v. Okay, next v is equal to integration of, what is the formula? Formula is y1 f of x divided by w dx. Okay, and this is just put the values of y1 f of x and w in this formula. So this is equal to, what is the value of y1? Y1 is what? E to the power minus x. You can see here, if you forgot, you can see here y1 is equal to e to the power minus x. Okay, and just putting the value of f of x, that is 2 upon 1 plus e to the power x into w, 1 upon w. What is the w? W is 2. So the 1 upon 2 and this dx. Again this 2 get cancelled. We left with e to the power minus x divided by 1 plus e to the power x dx. Okay, now how to solve this integral? This is the important step. How to solve this integral? Any suggestion? Let me write it as e to the power.
So plus 1 minus 1.
Now give your suggestions. I have just written e to the power minus x
So
as
we
1
can
upon e to the
divide
power.
e raised to-
Yes.
So we can divide numerator and denominator by e raised to minus x.
In this step, in this integral.
Yes, sir. We can divide numerator and denominator by e raised to minus x.
So what we will get? We will get e to the power minus 2x at the numerator and e to the power minus x plus 1 at the denominator. Then
The
what?
same answer which you have written, the same answer we will get.
Yeah. Now here I can do one adjustment. 1 plus e to the power x minus e to the power x. Okay, let us see what will happen. E to the power x 1 plus e to the power x. Okay, dx. Now I'm considering this first as a first two term as a single term. Okay, and just separate the integral and separate the denominator. So we get integration of first 1 plus e to the power x get cancelled. Okay, with this, and we left with 1 upon e to the power x dx, and minus this second term minus e to the power x upon this e to the power x also get cancelled, isn't it? So we left with only 1 upon 1 plus e to the power x dx. Do you understand this step? Yes.
Yes, sir.
Yeah. Okay. Now integration of this first term is very simple. What? This is simply integration of e to the power minus x dx. Okay. And for these again we will use that adjustment. What that adjustment? It is simply 1 plus e to the power x minus e to the power x. One more time. So we have 1 plus e to the power x at the denominator dx. Okay. Now let us solve it further. We get the answer of this e to the power minus x divided by minus 1. Okay. And for these, let me treat first two term as a single term and then separate the denominator. So we get minus integral of this 1 times dx. This whole term get cancelled, and because of this minus outside, we get plus sign. Okay, so we have plus times integral of this e to the power x divided by 1 plus e to the power x dx. Okay, now we can see this is simply minus e to the power minus x. Okay, and integration of 1 is minus x. Okay, and what is the integration of this? Yes, it is again that formula, integration of f dash x upon f of x. According to that formula, we have log of not f of x, 1 plus e to the power x, log of 1 plus e to the power x. Since integration of f dash of x divided by f of x, it is equal to log of f of x. That formula I used in the last term. Okay, and we got this as a value of v. This is the value of v. Do you understand this integral?
Yes, sir.
Any doubt in this? Yes.
Yes,
No,
sir.
sir.
We understood.
Okay, very good. So this is the value of v, and we already found the value of u. Once you get the values of u and v, just write down yp as yp is equal to u times y1, u times y1 plus v times y2. This is equal to u times, what is the value of y1? Y1 is e to the power minus x, and plus v times y2 is e to the power x. Okay, and just writing the values of u and v. So value of u is already found, which is what? Minus log of 1 plus e to the power x. Okay, so minus log of 1 plus e to the power x into this e to the power minus x as it is. Okay, plus v times, what is v? E to the power x times v. What is v? This log of 1 plus e to the power x minus e to the power minus x, and this is the particular integral. And once you find the particular integral, last step, y equal to ycf plus yp, and that is equal to the roots minus 1 plus 1 is okay, c1 e to the power minus x plus c2 e to the power plus x. This is ycf, and yp is this as it is. Just have to write here. So minus log of 1 plus e to the power x e to the power minus x, and this term as it is. Okay, so plus e to the power x log of 1 plus e to the power x minus e to the power minus x, and that is the complete solution. Do you understand variation parameter method? Any doubt in variation parameter method now?
No, sir.